Hello, welcome to the science session. I am Himanshu and I am going to explain the topic of magnetic effect of electric current. If you have not subscribed my channel, please go to the subscription and press the bell icon so that you can easily get the notifications of my further lectures. So let's start. Force on a current carrying conductor in the magnetic field. Before starting this point, let's suppose a scenario that there is a two bar magnet having the south and south pole or opposite poles polarity here, and we move one bar magnet toward another. Then we experience is that the south and north poles are attracting to each other there, and hence there is a force of attraction between them. Now in other case, just opposite the polarity of one bar magnet and kept the same polarity of the another bar magnet. Now move the one bar magnet towards the another bar magnet. We experience there is a force, but a repulsive force, or the force of repulsion will be act on the there. The common thing between that there is a force is acting between them. The conclusion of this scenario or this imagination is that there will be the always force acting whenever we brought a two magnetic fields to each other. So this concept is explained by me to understand the concept of force acting on the current carrying conductor. In the previous lecture, I explained you that whenever there is a conductor and whenever there is a current flow inside the conductor, then according to the magnetic field will be generated, and in the direction where it explained by the right hand thumb's rule. If we stretch our right hand in such a way that the thumb represent the direction of electric current, then the fingers represent the direction where the magnetic field has to be determined, then the magnetic field is in the direction of the pushing direction of the palm. It means that the downward magnetic field will be there. So there is a magnetic field generated, and when this conductor kept in external magnetic field, so there is a force experiences. Got it? And that force experiences will be explained by the Fleming's left hand rule, or in which direction that the force experiences and what were the properties of that. Got it? Now what is Fleming's left hand rule? Let's try to understand. Fleming's left hand rule means if we stretch our left hand in such a way that the thumb, forefinger and middle finger are mutually perpendicular to each other, and if the middle finger represent the direction of current, the forefinger represent the direction of magnetic field, then the force act on that conductor in the direction of thumb will be represented by the direction of thumb. Once again, if we stretch our left hand in such a way that the forefinger represent the direction of magnetic field, middle finger represent the direction of electric current, thumb will represent the direction of forces. Got it? So this is the Fleming left hand rule that is explained, and that Fleming left hand rule is a very important rule whenever we are going to discuss about the direction of forces acting in the external magnetic field. Now external facts or interesting facts that you have to in the knowledge, then the magnetism that used in medicine, or what is the phenomena of magnetism that used in medicine. Medicine. Now as we know that human bodies have consist of billions and trillions of neurons, and that neurons having some ions in that in the form of NaCl, Na plus, Cl minus, K plus. There are some ions in our neurons, and human beings contain the billions and trillions of the neurons. So whenever these ions are reflected, for example, we senses a something, we senses a hot thing, we senses a cool thing. Whenever there is a reflection with our brain, that means there is an action potential, means there is some potential will be generated, and this potential is due to the movement of the discharge ion. This is the ion or the charge plus charge minus charge. If this charge is moving, it means it's starting the flow of electric current, but this current is not so much high though we can get the electric current and all that. Yes, So it will generate the electric current in a very small amount. So this will start in electric current, and then electric current will generate through the magnetic field. Or in other words, we have said that whenever there is a charged particle moves, it generates electric as well as magnetic field. Now, why we are understanding this? This generates the electric and magnetic field, and due to that, in our body there is a magnetic fields in our around. It's very small in quantity, one of the billions of the Earth magnetic field. Okay, yes. So there is a magnetic field that inside our body, and on the basis of that, it of image is obtaining of the different part of body. You heard about the MRI, magnetic resonance images, magnetic resonance and imaging, magnetic resonance images, MRI. So this magnetism phenomena is very helpful in the MRI or in the medicine purpose. Now let's move on the topic of application of this principle or this theory. Electric motor. Electric motor is a thing that we broadly use in our day-to-day life. Here the electric motor are used in the refrigerator, our fan, mixer, washing machine, computer, MP3 player. Now how this principle or the concept that we have studied, that the current carrying conductor whenever kept in the external magnetic field will experience a force, how will this principle act on this electric motor, or let's explain the electric motor principle. Let us consider a magnet here, north pole and the south pole. This is the two pole magnet, this is the two pole magnet, and it is direction from the north pole to the south pole. The magnetic field is from the north pole to the south pole, and direction is like that. And a rectangular loop, a current carrying rectangular loop is kept in the external magnetic field. A current carrying rectangular loop is kept in the external magnetic field. That's it all. These are the slip rings, and this is a wire that is connected to the battery, minus plus battery B, here key K, and is connected to this. This one is called the slip ring S2. This one is called slip ring S1. The slip ring are the things things that is stationary or connected to the wire, that is not movable, that is fixed with the wire, or you can say that the movable part is the rectangular loop. If the loop is movable, but the slip rings are in stationary. These are the axle, is a rectangular loop, and now the direction of current, whenever there is a battery connected, the direction of battery is this, current is this, from this side to this side, like that. Let us, this part is AB and this part is C and D. Let us consider this part is AB and this part is C and D. Now how this concept of, that is the force experienced by the electric current and conductor in an external magnetic field, let putting the concept on this, and let's understand the phenomena of this electric motor. Now this is a current carrying conductor, and the current direction is from A to B, and here is the current direction from C to D. An external magnetic field is there because of the north and the south pole, from the direction of the north to the south pole. Now after that, this loop, this rectangle loop is in the same direction of the magnetic field. You can say in the parallel direction of the magnetic field. Like that, if the blue sketch represent the direction of the magnetic field, then the red one is in the direction of the or in the way of where the loop are there. So they are in the parallel. Okay. The blue part, the part A to B experiences in which direction force will be explained by the Fleming left hand rule, and also the part C to D experiences in which direction force will be explained by the Fleming left hand rule. Now, remembering the Fleming left hand rule, if we stretch our left hand in such a way that the middle finger represent the direction of current, forefinger represent the direction of magnetic field, then the force experienced on the current carrying conductor in any external magnetic field is represented by the thumb. So let us apply this concept in this. The magnetic field is direction from this, the current is in the direction this, then the force is in the thumb direction, means the magnetic field is in this direction, current in this direction, then the force acting on this coil is in the downward. The force acting on the side of A to B is downward. Let's say force AB. Now in this case, side of C to D, we again apply this concept. This is represent the direction of magnetic field, this represent the direction of electric current, that is from here. This is direction of magnetic field. Then the thumb will represent the force direction. The thumb is in upward direction. So there is a force that the part CD experience in upward direction, that the force on CD part. Due to that, there is generated equal and opposite forces with the different line of action, and it will always cause a torque or the rotation. Don't hesitate with the word torque. It's just simply understand whenever there is a different same force with the different line of action in opposite direction, then there is the rotation occur, and the rotation is occur along the axis is like anti-clockwise. This first case is for the 0 degree to 180 degree. Now let us understand the second case, 180 degree to 360 degree. 180 degree to 360 degree. Now, as the current flow in the wire, this rectangle loop from A to B, this direction of current from A to B, B to C, C to D, and the external magnetic field from there, then the direction it will move anti-clockwise, and as result the part CD is come here on the left side and part BA goes on the right side. Due to that, but the biggest advantage of this circuit, we use the slip rings that I said earlier, that these slip rings are fixed at its point and is connected to the wire. The movable one is the coil. Now the phenomena will be this. This is the rectangle one. This is the axis. This is the slip rings. This one is the remain S2. This will remain S1. This is movable coil. So C and D here, B and A here. The magnetic field in the again in the same direction, because these magnetic field are the constant. This magnetic field is a constant in this direction from north to south. Got it? So this current, as I said, this slip rings is attached with the battery with the K key, minus plus battery. This positive side is always on the S1 side, and this negative side is always on the S2 side. This is the plus one and this is the negative, always will be there because they are fixed. So this plus is the this side, and this S1 attached with the part of CD and S2 attached with the part of BA. So according to that, the current start flowing from D to C. The current start flowing from D to C in this direction, and from here the current start flowing from B to A in this direction. See, again whenever there is a rotation occur, the part CD come on the left side, the part BA come on the right side. The magnetic field direction is the same. The current direction is only reversed by due to the slip ring S1 and S2, because these are the fixed and directly connected to the battery. So there is a polarity is the fixed. S1 contain the positive polarity, S2 contain the negative polarity, and the current starts to moving in the opposite direction from D to A, from D to C, and C to B, then B to A, and then in this direction. In this way the current start flowing. Now again we apply the Fleming left hand rule in order to get the direction of the force. See, the magnetic field is in this direction, the current is in this direction, then the force is in downward direction. From part of the C to D, the force will be the in downward direction, and this will be the in upward direction. The force B to A or B on A or A on B is same. So you see that the force direction is same in both the cases. Here on the left side the force direction is the downward, here on the right this downward, here on the right side on the CD part the force on the upward, here is the same on upward. So this coil again move in the anti-clockwise direction. Anti-clockwise direction. So in this way the coil moves from 180 degree to 60 degree, and this phenomena will continue, and in this way the motor rotates. So in other words, the electric motor is nothing but it's a transducer which converts the electrical energy into the mechanical energy. And we see the application of the electric motor in broadly that in our day-to-day life, in the fans, electric circuits, refrigerator, computers, music players, and all that. So this is the very best example or very best electric motor explanation what we are going to do. So thank you.